In this second part of this video, what we're going to do is we're going to revisit the problem of doing this concatenation of two strings. And this was the first style that we looked at, was using the imperative style of programming and using the do block. But what I'm going to do now is I'm just going to open up my Haskell shell here. And the first thing I'm going to do is I'm going to show you, I'm just going to do an info. I'm just going to do an info on IO. And one thing that you will see over here is that the IO is basically an instance. It's an instance of monad's type class in Haskell. But in addition to that, the IO is also an instance of the functors type class in Haskell. Now, what does it mean of IO being an instance of the functors type class in Haskell? So if I were to do an info, let's say on functor, one of the things that I'll see over here is that the functors type class in Haskell is something where I need to provide the implementation to the fmap method. So let's do this. What I'm going to do now is I'm just going to take this screenshot from here from my shell, and I'm just going to play with this a little bit on my blackboard. So let's just take a screenshot over there, and let's just go back to my board here, and I'm just going to show you a second style here where we're going to start using the idea that an IO is also an instance of the functors type class in Haskell. Okay, so what I'm going to do now is the second style I'm going to show you is that now that I know that f over here is basically my IO, meaning that IO is an instance of my functors type class. Let's just go ahead and change this the type signature for my fmap as follows. I'm just going to replace everywhere I see an f with an IO. So let's just rewrite this. Let's just rewrite this as follows. Okay, I'm just going to make that IOA, and then I'm going to replace this F over here with an IO of B. Okay, now this is interesting because what I see here is that if I look from a purity and from an impurity perspective, I see that I have this method over here which is completely pure. This method over here is a pure method, meaning that it doesn't have any side effect associated with that method. There's no monadic term, there's no monadic expression in this purity. So what this tells me at a very high level is that, look, if you have these two impure terms, A and B, they're completely impure, meaning you may have got that from the outside world where you have impurity present, and you would like to take these impurity terms and somehow combine them together, right? You want to combine them together, and maybe you have this pure function that's currently available at your disposal. Okay, so let's do that. Can I somehow combine this idea with what I did previously, where I had this plus plus operator, which was my pure method. This was my pure method, and I had these two impure terms, which were basically my getLine and getLine, which are basically my IO strings here. So if I were to somehow use the idea of the fmap here, I can say, all right, look, I can call my fmap method by passing in this method plus plus, which is my concatenation. Now what this plus plus actually does is basically, I mean, from a string perspective, it takes in a string, and it gives you back a string as an output. Now if I were to apply curring over here, this is completely identical to what's the signature over here, where I have my I have my first input over here, which is of type A, and then I have this output, which is in this case a function, which is of type B there. Okay, so if you can see, this completely matches my type signature of my generic fmap on just as highlighted over here. Likewise, the second argument over here must be some kind of an IOA. Now A is acting as a string here, so I can say, okay, look, my second argument is this impure term. So why don't I just pass in getLine directly? Okay, so I'm just going to pass in getLine. Okay, so what does fmap plus plus getLine actually give you? Well, fmap plus plus getLine was going to give you is this output in this case, which is represented by IOB. But what it really gives you is this. is this IO of string to a string. So it basically gives you this method. It gives you this method which has been wrapped. It has been wrapped inside the IO monad. So you have this method that takes in a string and gives you back a string, and this method has been completely wrapped in a IO monad. Okay, so this is a type. This is a type of this entire thing. The type of this entire method, fmap plus plus getLine, gives you something of the kind of the type IO of string to a string. Now, in addition to this, I can now make use of an applicative functor. I can make use of an applicative functor. So I can take this entire expression, which is over here, and use an applicative functor by passing in get line. But before I proceed further with this idea, let me first show you what an applicative functor actually is. And we're going to just pause here in this video, and we're going to take this idea and explore this a little bit more further in my second in my next video.